Hello there and welcome to this workshop on Pandas Challenge Day 7. My name is Valentine and I'll be your instructor. In this workshop, we are going to be going through a set of Pandas concepts that are important when it comes to performing data analysis, manipulation, or data exploration. And the idea is that by the end of it all, you should be in a position where you can say that you can work confidently with the mentioned concepts in relation to Pandas. This is one of the many challenges that we have on Pandas, and if you would want to follow through this challenge, we would highly advise that you start at the beginning, because we build up the concepts over time, and yeah, so you can be able to work towards other challenges or other concepts that again will be important still when you're working with the Pandas library. So to get started, you need to visit the description section of this video, click on the practice resource link, and it should take you to a page that looks like this. Then once you get here, click on link. That's the sample practice link, and then you will get to a notebook that looks like this. So we're going to be using this to practice Pandas concepts, and we'll provide again challenges. If you're an Afterwork member, we're going to be using the practice notebook, which you should already have. And if you would want to practice more, do consider becoming an Afterwork member. So once we get to the sample notebook, the first thing that we need to do, let me just even zoom in a bit, is to go to file. So you need to go to file, then save a copy in Drive, and you should have a new copy of this notebook that you're seeing on my screen, and then you can close down the original one and work on that copy that you would have. You can rename it to whatever name that you want. Once you do that, the next thing that you need to do is just click on connect. For my case, I'll just be working with the practice notebook, which is similar to the sample notebook. The only difference is that there are more challenges for other sections. But generally, so let's do that. So let's click on connect. I will just open mine in playground mode. No need for you to do that. And so that I don't make any changes to the notebook, then I click on connect. So click on connect as well to connect your notebook to Google servers. And if you feel like I'm too fast, feel free to pause the video, rewind, and try to just understand probably what you might have missed from the explanation given. So once you've connected our notebook, we need to import the Pandas library to get to work with it. So this is how we import it, import pandas SPD. Then once we've imported it, we can now go through the concepts. So the first concept that we're going to be learning is how to sort data in descending order. It's a concept that we've gotten to have worked on in the past, in other past challenges, but again, because this is a series of challenges, the idea is to reinforce the same concept over and over. You might get that we have already covered this in like two challenges, either day 3 or day 4, I'm not sure. But again, you also find variations, like sorting in ascending order or descend or by multiple columns, etc. So let's load this data set that we're going to be working with, which we have here. This is the data set that we'll be working with, and we would want to sort the data set or the records by the salary column, so in descending order. So this is the column, but we want to have the greater values at the very beginning. So we could have maybe 100,000, then the lower values coming in last. So how we do that is we apply the sort values function to the data frame that we have. The data frame is a tabular structure that contains our data, which we have here. And we apply it to the data frame, and we specify inside that function the value for the by parameter, and this will take in the value of the column that we want to sort by. Normally this is a string, it's just a string, the name of the column, and we put a quotes. In cases where we want to sort by multiple columns, we would use a Python list, and we'd have multiple items, and we'll get to see that in the next section. And then we specify the second parameter, which is ascending, equals to false, and by this just means that we would we would set the ascending the ascending parameter. It just means that we would want to sort the records in descending order. If we set the ascending parameter value to true, like this, we would get it as records from the lowest to the highest. And then once we do that, we store the values, the records in sorted data, and then we display the sorted data. So if we display that, we should be able to see that the first few records, so the highest value is 95,000, etc. So for the first records have higher values than the bottom records, which we have here. The ones at the bottom are the ones that we see here. Right, pause the video and then work on the challenge. We can also sort by multiple columns. So I mentioned earlier that here we had sorted by salary, but only defined just one column. But if you want to sort by multiple columns, we can define a list, a Python list, which is a data structure that contains items or elements. And, we specify the item. So the first item will contain the column that we want to first of all sort by. Then once you've sorted by that particular column, we then again sort by salary, taking into consideration that whatever that we have here will be constant. So, and then in ascending, we also define another list that will contain the definition of how we want to sort the values by for each of the specified columns. Like for department column, we want to sort it in ascending order. That's why we set it to true. And for salary, we want to sort it in descending order. That's why we set it to false. And so we'll have department values, records sorted by department first. So here we have finance. But again, within, say for finance, we would then again sort the salaries in descending order. So when you look at salary, the first record that comes is the greater one because we've sorted it by in descending order. Then the second one would be 94,000. That one would be but you can see, you can understand that for salary we've sorted it in descending order, like the way we did here. But for department we've sorted it in ascending order. So the value finance actually comes before the value marketing because F comes in before the value M in the alphabet. So that's how we do that. Pause the video and then work on the challenge. We can also perform ranking using the min method. So ranking allows us to be able to assign ranks. So for instance, in a case which is usually a good example, if we had student scores in terms of their performance in an exam, we can rank those students by giving them just a number. Like this was the first student, second student, third student, based on the scores that they got for that exam. And we can generate that rank, that value using Python, and we use the rank function. So for instance, in our case here, we are going to load this new data set, but we are going to create a summary table. So we're going to create a summary table that will contain department and salary. And then we're going to rank the departments based on the salary column. But now we would want to have the minimum salary coming first at the very top, instead of having the maximum values for salary. So the minimum salary will come at the top, then the other values, and the last one will actually be the one that will have the highest or maximum salary. So if we run this, which we are going to get, what we're doing here, we are grouping, we're creating that summary table, and then we apply the rank function to that summary table. And that will give us the rank column. That would mean once we have that rank column, so we are going to have this employee ID, first name, last name, department, salary, then rank, but the rank value will represent the rank for the department when it comes to salaries. So if you run this, you should be able to see that particular value. All right, so moving on, pause the video and then work on the challenge. We can also apply custom functions to data frame columns. So instead of applying a specific operation, let's say like ranking or creating a new column using some inbuilt function, we can decide to define our own function that performs a specific task. This is where they usually say that with programming languages, you can code anything that you imagine, because you can create a function, which in our case would be a Python function, and it would perform any desired task, mathematical task that we want, to the data frame columns. Not even mathematical, but any sort of data manipulation task that we might have in mind. So the complexity of that function would actually again be dependent on the complexity of the operation that you want. So for example, if we load this data set and we understand how it looks like, we might want to maybe have a new column. This might have been, the salary that we have here would be in USD, but we might want to have that in euros. So to be able to find the equivalent of that, that's euros, we would need to create a custom function, because ideally there isn't a Pandas function that allows us to perform that USD to euro function. There are libraries that can allow you to do that based on real-time data from reliable sources, but for a case when it comes to Pandas, we would need to create that function. But we can still use Pandas with other libraries if we wanted to. So we use the def keyword to define a function, then name the function USD underscore to underscore euro, and then we will have a parameter called salary. That's what we give the function as input. And inside the function, we specify the exchange rate. This is where if we wanted to pull some data from an external source, we could define here. But again, we just want to learn how to just apply custom functions to a Pandas data frame. Then we return salary times exchange rate. So the value of salary times exchange rate. So then once we do that, this function, we can apply it to the data frame that we want using the apply function. So so that's what we do. So here we are specifying the salary column, the F salary, and then using the apply function and passing in a parameter which will contain our value, which is actually the function that we want to apply to the salary column. And the output of that would be a new column called salary underscore EUR, which will contain the euro equivalent of the salary values that we see here. This is with the assumption that what we have is in USD. And then we display that. So let's run this. And we can be able to see that we have what we have on the far right. Salary, etc. All right, pause the video and then work on the challenge. All right, we can also decide to, as part of data manipulation, maybe replace some values in a column based on certain conditions. So for example, we could decide to replace if salary is less than 80,000, we could replace that maybe with 80,000. Sometimes if maybe department is IT and maybe the IT department has changed its name to maybe tech, then we can also apply the same operation to it. So we can do it for string or textual data as well as numerical data. So just to elaborate how we can perform this task is we would need to use the lock method. So there are two actually options. We can use the apply method or the lock method. So here we specify it and we actually apply it to the original data frame. And we specify that we want to, inside the lock method, we specify our condition and also the new value that we want to you know, the new value that we want to apply. So this is the actual new value. So here, this is our condition. This is the condition that we want that to apply, and this is the column that we want to apply our condition to, and the new value that we want to apply our condition to. So so the new value will actually replace where this particular expression turns out to be true inside this column. And that's it generally. That's what we would do. Okay, all right, pause the video and then work on the challenge. In cases where we are working with time inside our data, so for example, if we have this data set and we wanted to maybe retrieve records, like filter for records, and we had a time variable, like joining date on the far right, we can decide to perform what is called time-based slicing, which just allows us to filter for records between a certain specific date. So how we do that, we first of all, just like in the past, convert the date column that we want to work with to have a date, we convert it to a date time format. Once we have done that, the next thing that we would need to do is to set the index. So this would be, you know, we could set it as the index of our data frame. And then once we do that, this is one of the methods, by the way. We can also use another technique. This is just one of those methods that we can use to perform time-based slicing. So if you're wondering why is it this long, but yes, this is one of those methods. So once we have done that, we set the joining date as the index of the data frame as shown. So we use set underscore index, then pass the column that we want to set as the index, and use the in place parameter and set it to true to apply the change to the original data frame. And then we decide to sort the index. So we ensure that our data frame is sorted by index, so that again, when we are performing time-based slicing, we do not get errors, or we do not get an unexpected outcome. And once we have done that, we just then perform time-based slicing. So we define the start date, end date, and then we specify the slicing technique. So we want inside df column, we want to get the start date, the records between the start date and the end date. And then we preview the data. And that's basically how we just get the outcome of our data. So here, we have this as the data that we want. We have joining date, which is the index, and then we have our data, which when you look at the column for the column, or that's the joining date column, you can see the dates are actually between 2018 and 2019. Pause the video and then work on the challenge. Alternatively, instead of using that technique, we can use the between function, which allows us to sort data, or filter data, not sort, filter data based on a specified date range. So for example, in our case here, where we have this data set, which has joining date as the column, that's the date column that we're going to work with. We first of all convert it to have it a date time format. And once we have done that, we can decide maybe to select records that are between from a certain range, like from this range that I've highlighted here, 2019 December, 1st of December 2019 to 29th of December 2020. Then once we have done that, so once we have known that this is the range that we want to filter for that, we simply use the between function as shown. So we specify the column and then we apply it to the between. We apply the function between to that particular column. That's the date column that we want to work with. Then inside the between function, we set the start date and the end date. And generally, that's basically it. Just filter for data and preview the first 5 records, just for ease of understanding. So when you look at the data itself, you can see closely that we have these records which are between the specified date. That's 2019 December 1st to February 2020 29th. All right, pause the video and then work on the challenge. We can also create a summary table using a pivot table function. So initially, when it comes to creating pivot table functions, we got to interact with the group by function, but the pivot table function is another way of generating summary tables. So for instance, if we wanted to create a summary table out of this data set that we have here, and we wanted that table to have department and the mean or the average salary columns, then we can use the pivot table function by simply referencing it from Pandas, like pd.pivottable. We specify then inside that function, the first parameter would be the data frame that we want to create a pivot table from. Then we set the index of that particular summary table that we want, which will have some department. That's the column that is going to be on the left side of our summary table, and on the right side we want salary, and we specify that column using the values parameter, and again for salary we want to get the mean, so we also specify the aggregate function. So these are important components. There's an index, there's values, as well as the aggregate function that we would essentially use to create a pivot table or summary table using the pivot table function. Lastly, we set we reset index. We use reset index to just ensure that we get a Pandas data frame as an output. So we run this. Once you run this, you should be able to get what you have here, which is now a neat table that looks super. You can create visualizations with it. All right, moving on. Creating a line plot using, by the way, you can pause the video and then work on the challenge. Moving on, creating a line plot using the plot function. So in some cases, we might want to quickly create a visualization, a line graph. If we don't want to use maybe matplotlib or Seaborn or other libraries, maybe this might be an easier way. So how we do that is, first of all, we can run this particular code. So to just get to preview the data frame. So we are going to have a line graph for joining date versus salary. So we'll have joining date as well as salary over time. Not the best case, but this is just for demonstration purposes. I think one can do a different visualization for that, even work with a different data set for creating a line chart. But for ease of learning, we'll use this example. So we convert joining date column to a date time format. That's what we do. Then we sort the records by the joining date column in ascending order, so that we have, because in a line graph, like in our case, you were going to have a time series line graph. So the idea is that on the x-axis, we will have date, and on the y-axis, we are going to have salary. Yeah, so that's what we do. We sort the records, and then once we have done that, we set the index as the joining date column as the index column, and then we create our line plot using the plot function, and we specify the value for the kind parameter as line, and the title is shown, and run that. And this is our visualization. All right, pause the video and then work on the challenge. Handling missing values, so with the k nearest neighbors imputation. So this involves using machine learning to handle missing values. In the past, we got to learn how to work with missing values, or to handle missing values using a range of techniques like mean imputation, arbitrary imputation, where we just replace the missing value with a constant value. It could be 0 or 1 or whatever value that makes sense. And we also dropped missing values. In our case here, we're going to intelligently come up with accurate values that can be used to represent what's missing in a data set. So one of the machine learning techniques, or these techniques, this technique that we're going to be using for imputation, for finding that reasonable value, is called the KNN algorithm. And this is a machine learning technique that allows us to study the data set that we have, and use that data set to approximate values that could be missing in the data set. So so let's get to learn about this. So first of all, we load this data set, and we're going to check for missing values. You can see there are some missing values in the income column, actually two, but we can use the technique that we have here to just see other missing values, how many missing values we have for other columns. We can see for income we have 3, education 1, etc. Now, to use the KNN algorithm, we would need to import it from a library called sklearn. This is a machine learning library. Again, by the way, we're learning how also to integrate, in this case, Pandas with another technique, but because Pandas is quite known for data manipulation, it's important again to learn even how to integrate it with another library to be able to perform specific operations, which are not available in Pandas. So in our case, we import the KNN imputer. It's a class, it's a Python class. Class is just a way of organizing code when it comes to Python. So we're going to import KNN imputer, and then here we technically create that is called an object. But yeah, so we instantiate, let me just say, we initialize the KNN imputer. So we get this code that performs imputation using the KNN algorithm, which essentially how it works is that it learns from the values that are closest to the one. It learns from the records that are closest to the one that is missing a value, and then depending on the number of records that you want, like here we specify n nearest neighbors to equals to 5, so we just mean that 5, we want to use 5 of the nearest records, of the closest records that are similar to the one that we are looking for an imputed to for a value for the missing value, and we are going to use that. So that's why we're saying n neighbors equals to 5, so we specify that. Initially, sometimes you might not even need to specify nearest neighbors, but can specify it as that. And then we apply now this particular, so we create now the imputer, which is just KNN imputer. That's the code that's going to be applying the KNN technique to a data set. And then we use the fit transform function from this object. Again, an object is just a copy of a class. KNN imputer is a class. So we get a method called fit transform from it's not a function, it's a method, from the imputer object. And then we apply, we pass to it the column that we want to apply the imputation to. And we replace now, we get those new values that are missing from the age column. And we replace that with the existing age values. So what we will get here will be column values for age that have no missing values. So yeah, so and then we just simply do now that replacement of the old values, and we check for missing values. So for age we had 1, but now here for age we have 0. And you can also do the same thing for other columns. Pause the video and then work on the challenge. All right, so that's it with regards to day 7 of our learning experience. We hope you're enjoying practicing. If you did love this experience and you would want to tell us that we're doing a good job, be sure to give us a thumbs up. And if you'd want to be informed when we post such future challenges, be sure to subscribe. All the best in your learning journey. Bye. Bye-bye.